Let's go ahead and do this last problem on Module 4, Lesson 8, and then I do have to end the video after this problem, so because the next one is a new packet. So this will just be a short little video, and as you can tell, I'm using recycled paper. I'm trying to save money, so sorry you can see through that, but we get the picture, right? Okay, so we say similar triangles. Okay, so they're telling us they're similar. Find the missing length. And students struggle with these after I show them the little trick. They're like, oh, you're kidding me. That's so easy. So you're probably going to say that too. So what a lot of students don't realize when they look at this picture is that there are two triangles involved in the picture. One is inside the other. So that's one triangle. And the other triangle is this. So what my first advice is, when I used to teach geometry in high school for years and years and years, I say, pull the triangles out of the picture. Make them look like this. Wasn't this problem so easy? Well, do the same with that. You don't have to keep them in this complicated picture. So let's first pull out the yellow one. So when we pull that out of the picture, we can see its height is x and its base is 12. Okay, now let's take a look at the big picture, the big triangle. Its height is 8, and this is where you have to be careful. Don't write 8 for its base. Its base is both of these. That's a 6, sorry, I said 8. Looking at this number here. Okay, do you see why? So I can't write 6 for this pink triangle. I can't write 12. It's the two of them added together. So it would be 18. So 6 plus 12. So that's usually where the mistakes are made. If this one, either students don't do it because they forget to take them out and separate them like this, or two, they get this measurement wrong. I mean, it's easy to see this as x and 12, but when you're looking at the pink triangle, it's both of those together. So it's 6 plus 12, which is 18. Now we got an easy schmeezy problem like we had above. So I'm going to circle the like ones. So x corresponds to 8 and 12 corresponds to 18. And remember, you can also do height to base, height to base. I'm just going to keep it consistent like the example showed, but you can do either way, you get the same answer. So x goes with 8. So that's my first fraction. Remember, I have to stay consistent. Left triangle is to its corresponding partner on the right triangle as left triangle. So don't do this. X over 12 equals 18 over 12. Why do I keep saying the wrong number? I guess because it's too late at night. X over 8 is not equal to 18 over 12. You have to go left to right, left to right. So x over 8 equals 12 over 18, not 18 over 12. That's another thing I see students do. They kind of like want to make a circle of it, but you're not being consistent then. So both parts of the left triangle should be in the numerator. Both parts of the right triangle should be in the denominator. And this one doesn't have an obvious constant ratio or scale factor. So why don't we just practice our algebra from Module 3. So 18 times x equals 8 times 12. And it says to write our answer as a whole or mixed number. So that means no decimals. Okay, so let's do 12 times 8 over here. 16, carrier 1, 96. So 18 times x equals 96. And then we learned in Module 3 to divide both of those sides by 18. So then we get x equals, and they want a mixed number. So let's go up here and do our division. So that would be 96, and remember how this is always the one that's outside, divided by 18. So 18 into 96. So 18 times 3 is 54. 18 times 4 is 72. 18 times 5, I think, is 90. Let's see, 40, carrier 4, 5, 6, 7. Yep. So that looks like that's the one we want. Subtract, we get 6. So remember, it wants, oh, Kim, off the page. I wish you guys were yelling louder. Get it on the page. Okay, so our remainder is 6, and our divisor's 18. But do you see how that simplifies? 6 and 18 are both divisible by 6. So that leaves us with 5 and 1/3. Let's write it here first, then we'll bring it down. So we divide whatever the remainder is, we put in the numerator, and the denominator is the divisor, then we divide both and simplify. So that would be 5 and 1/3. And again, we don't have any inches or anything, which I think is a bummer because geometry problems should have units. So because the original problem didn't have any, that means we just stop right there. So see, I told you that was a fun problem, huh? Now you know how to work it. We call those nested triangles. So when they're nested, as they were in geometry in high school, you pull them apart into two separate, and then it just turns into a nice, easy problem from there. You'll see it in quite a few classes. I have a problem or two problems like it in Math 120. So you'll see it again. Okay. So 5 and 1/3 from our picture. Could have boxed it up here, I guess, too. Okay, so I'll see you in lesson 9. Bye.